All right, hello. I've been having issues with this controller. I think it has something to do with this wire coming out of it. We're gonna crack it open together and see. Fingers crossed that this is the issue right here. Take a look. We got a pinch. And I don't know if you know stuff about wires like I do, but metal, and this is metal sheathed in it's typically either silicone or plastic, depending on the grade of wire you get. But the metal here in this little gap, I don't think it'll quite show up, but the metal here, it's stranded copper. And a lot of the main reason why wires are stranded when you see a stranded wire is due to allowing the wires to move freely. When it's a single, just solid core wire, any bend that you put into it will leave a major impression in the wire, and it'll just want to break. However, if you strand it out, you're having a bunch of tiny wires that all can flex in their own way, which typically gives you a healthier wire. However, even this stuff, this stranded wire, can still bend, deform, and eventually, if you just keep rocking it back and forth like this, the metal will fatigue, it'll outlive its useful life, and it will start to snap and partition off, which is what I think is happening in here. Usually wire doesn't bend like this until there's some pretty serious kinking that happens. And a kink is when the wire looks like that, which you never want. You want to try to keep this wire as straight as humanly possible for as long as possible to reduce damage to it. However, this controller is already kind of effed. I've tried it on multiple computers and I seem to keep having the same issue of just if it goes in the wrong way, if it goes in the wrong spot, my controller disconnects and doesn't want to reconnect. So I think that has to do with the wire here being fatigued and the metal connections breaking, which I think I can just resolder together and that'll fix it. However, and also do this. You don't need something like this where it's separated by grates, but whenever you take apart electronics, the bolts here, these little guys, these are bolts because they're entering a threaded portion. Make sure that you map where you pulled the bolts from. You can call them screws if you really want to. But keep track of where each of these bolts go. So I have put my top two on the top rack here, and that translates to this. I've put in the middle three on the middle row. 1, 2, 3. And then I'm taking off the last two. I'm gonna put them in the last row. And I do this because these bolts that are used to hold an electronic device together can vary in length. And if you put the wrong bolt in the wrong hole, you can tighten it. And if it's expecting only to go this far and the bolt passes through and goes much deeper than it should be because it's the wrong bolt in the wrong place, you can perforate a circuit board, damaging the components on the board. There's on my Mac, my 2013 MacBook Air, there's 2 really long bolts in the back and then all the rest are short bolts. And if you try to put a long bolt in a short bolt hole, like I said, you might puncture something, you might perforate a board, you might puncture a battery, which is bad because say goodbye to being able to use your electronics without being connected to power, which sucks. So I have a couple of theories of what's going on here. Either the connection of this wire to the circuit board is bad, which I don't envision. Although, if you remember those Xbox 360s that were from launch, they were pretty poorly made and they had about a 50% failure rate. So let's see in here. We have the 4 data wires from a USB. We have, well, sorry, 2 data wires and 2 power wires. And if you look at a USB wire, typically you'll see 4 colors, red and black, which is power, red, black, ground. Electricity wants to flow from wherever it's at to wherever it isn't. Is the easiest way to put it. There's something called voltage, which is the potential energy of the electricity just kind of jittering around in one place. And if the electricity has the option to travel to a place of lower voltage, and ground is a place of 0 voltage, it wants to distribute itself evenly wherever the electricity is contained. Electricity hates itself. It's negative charge, constantly bouncing and bounding against itself. So what happens when you are in the same room with someone you hate and a door opens? You leave, you exit, you go from where all the angry pixies are in the red side and you go to the black, because that's where the electricity ain't, and that's where you flow, and that's where you go. And then there's these 2 data wires. So the electronic device is powered via red and black, and then data flows, and typically it's like green and white or green and yellow, or just colors that aren't red and black. If I take a look here on this other USB that I have just chilling on my desk, it's a little tight to see. We got a couple of these white strands that are just used to fluff up the wire to protect the actual metal wire in here. But we have our unsheathed wire here, which is our ground. We have our red, which is once again our power, and then we have our 2 data lines. Looking at this board, I don't think I'm seeing any disconnection here. What I can do is I can check the connection with a voltmeter. I've heard it called both. This is a wonderful little device. This one's kind of a POS, just because I bought a cheap one. And if you're serious about voltmeters, like Fluke is amazing. There's some other companies that make good ones too, but any $20 device will last as long as a $20 device will last, which it ain't long. We can check a couple different things with our voltmeter. We can check voltage, and we have, let's see, I believe that's DC and I believe that's AC. We'd only need DC for this project because we're working with USB. USB is a DC current. Direct current, there's 2 types of current, direct and AC alternating. Direct is a flow of electrons down a wire. So if this, our USB, since we've already established it's DC current, on that red wire, electrons flow down into the device and power it. And then we have black, which is our ground, which is where the electrons return back to the input device, not the input device, the originating device. AC, alternating current, is electricity that travels not down the wire, but travels like ocean waves. The electricity pushes, so a bunch of electrons push down the wire a little bit, and then they pull back. And that vibration travels down the entire length of the wire to wherever the AC current arrives. So it's a little basics. There's typically, so like I said, positive, negative, green, black, data, positive, negative. From my understanding, it's a data send and a data return from the input device. I'm sending some information down, I'm receiving some information back. Okay, so back to our voltmeter. We can check voltage, we can check amps, and we can check ohms, which is resistance. Now, as electricity flows down a wire, typically we assume the resistance is 0. It's slightly higher. The electricity needs to spend a little bit of its own energy pushing through the wire. However, it's very minuscule compared to resistors, LEDs, things that use the energy for something. A resistor, similar to how its name sounds, it resists flow. So there is a voltage drop across a resistor because some of that energy is released as heat as the electrons push itself through the various slabs that exist inside that resistor. Because a resistor, it's a series of materials that resist flow of electrons. So that's kind of the basics of your multimeter. The only thing we're going to use on this right now is continuity. Continuity means, am I looking at a wire, or is there a break in said wire? So if I touch these two ends of this, the positive and negative leads of my voltmeter together, we will see this drop basically to 0. So 0.03. Like I said, there's slight resistance in the wires of this, of the wires just coming off the voltmeter. However, it's basically nothing. So 1, that 1 is infinite resistance. 0 is basically no resistance. So what I'm going to see, I think because of this kink in this wire, the metal's fatigued, and that is why my connection drops, because essentially there's a break in the wires and they keep touching and connecting, and then eventually the wire gets moved in a certain way where they disconnect and the electricity stops flowing, or the data stops flowing, or something. So what I'm going to do, I'm going to check the flow across my different data lines. I don't know why Xbox does this. They have this weird connector for a USB. So I can check ground really easily. Ground will always essentially be the connectors, the chassis. Wherever you see exposed metal, you can kind of assume that's ground. So if I touch this, and if I touch the black part of the connector, which I believe is, so that's red, green, red, white, green, black. Again, if I touch that, look, see, drops down to 0. So my ground connection, I think, is okay. I'm gonna jitter around this wire a little bit. I would have loved to have a, oh, I have my helping hands. Nick, you little smarty pants. I fixed these little clamps. These are helping hands. The one thing that you will realize if you ever get into soldering circuitry is you don't have enough hands to do all this crap. It's nice to have a little bit of assistance. So what I'm going to do is I'm going to touch ground here. I'm going to touch black here, which is my ground, and I'm going to see if this is the thing. All right, come on. Touch ground, touch metal, 0.2, 0.3. All right, and I'm moving this around, all around. I'm going to reconnect that, and I shouldn't see any change, which I'm not. So we're touching. I'm gonna kink that hard. Okay. I keep disconnecting that. All right, so I'm not seeing any issues with this wire. I'm gonna move on to the next one. I don't know which one is which in here. For some reason I have, oh, you know what? It might not be this kink here. It might be my actual header is fucked. But we shall see. I'm gonna touch the next one. So one of these is my data. One of these is my power. I kind of just want to break this thing open and see, which never works out well for me. Like, I'm assuming from this kink that that's what's busted. And also the power, the start button wasn't working. Okay. All right. Can this unplug? I think you unplug. Not. No, you don't. Let's test these to see if there's any wiggle room in there. No, those look pretty well fixed. So, let me see if I can find my positive in this little shebang. Oh, okay. So one of these is my power. That's my power. Okay. Now, the only issue is I have to move these. If I could just keep one of these stationary. This is what I mean about not having enough hands. I am gonna poke you. I'm gonna poke these. I'm not getting anything here. Okay, 26, 11, 1. Okay, 26, that's fine. It's not great. I should be seeing a little bit lower than that. It might be, which means that might be our kink, is in the power wire. Okay, there you are. Okay. And I'm gonna jiggle that power. Oh, there we go. 25. I'm gonna jiggle this wire around. 2. Interesting. All right. 24, 25. That's weird. I might just end up snipping these and resoldering them. But for the meantime, let's move on to the next one. So they're not the top ones. I'm on white. Okay, there we go. 25. Oh, there we go. 25. And all I'm doing here is I'm poking and prodding, trying to find my, let's see if it's an easier on the, might have an easier time on. So like I said, if I'm looking at the USB, the outer 2 are the power lines, the inner 2 are my data lines. Grab one of these data lines here. And it might just be my contacts are messed up. It might be my... There we go. 3, 2. Ooh. See that? Damn. It's not that one. There we go. No. Oh shit. I'm gonna bend this a little bit. Always make sure that whatever you're repairing, you're willing to lose. Always, always. That way. No, not that one. Let's try the next one. I have a feeling one of these wires is busted. There's a U. And okay, 2. Two, 1. This is my least favorite part, the not knowing. Okay. 2. Okay. Damn. This might just be a firmware thing. Let's try red again. 23. Oh. I'm trying to manipulate this in a way to see where if that break is happening. See that little jump? I don't know if that's ground or if that's... Like, I might just dissect this thing anyway, right here, to see if my assumptions were right or wrong. Because this controller is a decade old at this point, more than that. I don't like throwing away things that aren't fully broken. The best way to figure out if they're broken is if I break them. So, inconclusive. However, I still think the issue is what I'm describing. So I'm gonna crack this wire open and we're gonna see if I'm right or not, because otherwise, the nice thing about doing repair work on something that's already kind of effed is, you know, the worst thing that happens is you make sure it's effed, and then you throw it out or repurpose the pieces for something better. So I'm gonna crack open this wire. I'm gonna see what these kinks are. There's a couple different ways to open up some wire. You can just use a little knife, which is what I'm fond of, and you can just shave away little bit by little bit until you expose the truth. I don't have to shave away too much. Just enough to expose and see what's going on the surface. So, cut you open. And now I'm looking at unsheathed wire, which looks like it already has some splits and breaks in it. So it could very well be that the ground strip, all the ground strands here, were already fried. And because of that, you need both. You need the potential energy and you need somewhere for it to go in order for these things to work. I think you ever get death grips stuck in your head? Nick does sometimes. Alright, see all that mess? That's what's been happening to the ground wire. Whoop. And looks like Nick was right. See that? Fuck all that sheathing. Just look at this. Looks like we have a black wire that is disconnected. He disconnected. Looks like we have a break in that black wire. The rest of these look alright. But you are severed. So it looks like, yeah. Let's go fix our ground connection. So I'm going to turn on my Hacko. This guy's gonna turn on, get up the temp, and you, I'm going to cut away the rest of this sheathing. Be careful not to chop away anything you don't need to chop out. This is crazy. That wire just severed. I don't know if you're gonna be able to see that, but we have a black wire that's just disconnected. Now, did I do this? Maybe. It's the tough thing about electronics and repairing them is you never quite know who broke it. And even when you fix it, you never quite know who fixed it. There we go. So, I'm gonna get rid of all this shiz. The black wire I'm not too concerned about keeping clean. I just need to get down in there and find out. So it looks like our other wires are fine. They're still connected. It's just this one black wire. And I think the ground was relying on this sheathing to complete the circuit. No, the sheathing doesn't connect. So, something was going on with this. I'm pulling away the wires from where I'm cutting so I don't accidentally snip something and give myself more work. don't know if you've ever run into this either, but sometimes I'll just say F it and I'll do a whole redo of everything. And sometimes the little minor things can cascade into bigger and bigger problems until you just rip out an entire beating heart of whatever you're fixing. This is why multi-tools come in handy, because they give you multiple tools. And you want to be able to attack a problem from various angles. And you'll notice while you're repairing something, sometimes you can inch along and eventually get to the fix that you need to. You can inch and inch and inch and inch. And eventually you'll clear the finish line. Or you can switch up your strategy, and something that would take you hours could take minutes. Just depends on having the correct tool. Like, for example, I'm using this when I could be using my side snips and do even more damage even more quickly. I'm just looking for my black wire. Anything that's not that, I can snip away. So I'm just going to be eating, chewing away into this little... What this rubber stop is to alleviate stress on the connector. And you'll see this is just a common design. It's a common design solution. Imagine you're a little rage-filled 14-year-old COD player, and you lose a match and you rip your controller away. Now, if this little rubber stopper wasn't in the controller to essentially alleviate the pressure, so we're pulling against the controller body and not pulling against the connectors, this wire might get ripped straight out of this board, controller's dead. However, if you have this little rubber stopper like this, you have a way to translate the pulling forces to the controller's plastic. So you buy a little bit more rage time. Bring this out a little bit more so you can see what's going on. All I'm doing is snipping away at the sheathing. So I can find that little black wire that I lost. Sometimes we lose things, and that's okay. There you are. And then you just work at it a little bit, and it can be found again. And there's my little black wire. Now I want to keep this stopper so my little rage monkey brain doesn't destroy this controller. And this might not even fix my issue, but at least it'll give me some peace of mind. Repairs are always a game of guess and check, especially if you're repairing something new. God forbid. It's the worst. Because then you're in an uncharted territory. You don't know what you're diving into. You don't know what the best course of action is. You don't know how to undo or how... Essentially when you're in little black box mode, where whatever you're fixing is a little black box of wonders that you just don't know what's going on inside of it. You just gotta do your best. And sometimes you gotta pay tribute to the machine gods. And you just gotta offer up a blood sacrifice. So that the next one, at least you'll understand the inner components and you won't F it up quite so bad. So what I'm going to do here, whenever you're soldering loose stranded wire, twist it up. So I have some wire here. All I'm doing is I'm taking all those wires that are loose and I'm twisting them up. I'm going to the This is where my helping hands come in handy. Look at that, hands-free wires right there. Oops. Okay, so that's there. I have, see, this looks like it was sheared on multiple sides, actually. Dang, you got effed up, kid. There we go. So I have two exposed wires here. There's a couple different ways that you can attach these. You can solder tip to tip, or you can twist them together, which is always nice because then it's just all nice and compact. That's nice. I'm gonna go tip to tip just for cleanness. I'm also going to get some heat shrink, which is lovely, lovely stuff. Heat shrink is a plastic sheath for your wiring, so you can slip it on and make sure the wire doesn't touch anything else. So I'm gonna open this up, gonna sheath it, and like I said, I might have royally effed myself. It's very possible. And you need to be okay with that reality whenever you're repairing anything. There is a possibility that what you're fixing is already foobar and is beyond the point of no return and will never be fixed. There's a possibility that you will make it foobar. Effed up beyond recognition. Beyond all recognition. And as long as you keep these things in mind, it's not so bad. It's not so bad. You're just the best I ever had. So you can just take your soldering iron and just coax that heat shrink. Now this soldering iron is burning at about 500 degrees Fahrenheit. What I'm gonna do. So I have my wire here. I'm going to tin 110, meaning my soldering iron's nice and hot and ready to go. I'm going to touch it on one side. No, not quite. I'm going to get all the strands together. Getting the strands back together. I'm going to make sure any loose strands don't touch it. Like I said, this might not fix it. TBD. But I will tin it, meaning I will solder it up. I don't think there's enough wire there, actually. So what I'm going to do is I'm going to snip a little extra. I'm just going to teeth it. And give it a little nice tug. There we go. And that gives me a little bit more to work with. All I'm doing, heating up the wire so I can apply solder to it. Slip on a little heat shrink, because when you apply heat, it shrinks. A little self-explanatory. It's a little too much. And this is to protect the base. Oops. Also there. No, I'm losing enough where it's starting to make sense just to wrap these two guys together. So I have two exposed wires now. I'm gonna tap them together. Solder you. And then I got one set of helping hands. I could get the other, but what I really want to do is make sure that I can heat shrink this when it's done. So I'll have this come over after. Might have to just put on electrical tape. It's a little tight. So I take my two helping hands and I angle my wires in a way such that they tizzity touch. Or I can just hold them together. That works too. Because they're already soldered. They already have solder on their tips. I just have to touch them together. God, I'm being a pain in the ass. Let's try it this way. I'll angle it and bring you along, don't worry. There we go. So, typically you want to move the mobile part to an immobilized part whenever you're soldering two wires together. And this is NASA soldering. They are already tinned. They're touching. It's a little tight to see, but if you just melt the solder together, an awful job of this. Splatter some more solder in there. There we go. And we have two wires that are now soldered together. Now I'm going to plug this into a computer and see if I fried it. I'm not seeing, I'm wiggling the wire, I'm not seeing it disconnect. Nice. Nice, nice, nice. Cool. So I think my hypothesis was right. What we've seen is a wire that got, I think I ran over it with a desk chair at some point and the ground wire got severed. So now I think we're good. Fingers crossed. I'm gonna take some heat shrink again. I'm gonna snip it down the mid. Heat shrink typically works better if you don't do this. Word to the wise from Radio Disney. I used to listen to so much Radio Disney back in the day. I wasn't a Disney kid, but I loved Radio Disney. Nope. I know. You're not supposed to be down there. Word to the wise from Radio Disney. Word. Wise. So, just so you can totally see what's on the underside of this controller, these are pads, I think they're silicone, and they go under the buttons. So if I flip this over, we have all our buttons. We have our start, Xbox, the directional pad, the A, B, X, Y. These are all floating pieces of plastic here. Look at that. And a silicone mat sits behind them. And these are keyed in a certain way. So if this comes out and if it's not sitting properly, that's because it has these keyways. Well, the body itself has a keyway, and then these little plastic pins on the side of the button. They're a little tough to see, but there's one right there. You have to orient this correctly so that it drops in. I'm going to do that once more. Keys aren't lined up. Keys are lined up. So each of these buttons is keyed to a certain spot on to keep its orientation and to make sure that it only travels linearly in the body. And once you line up the key, it drops in place. And then you put on this silicone mat, which has these black conductive pads. And these pads, they are originally like this. They're flush, they're below the mat. And then when you press the button, the pad pops out when you depress the button on the other side. And this pad, this little black bit in here, comes down and touches a conductive pad on the other side of the controller, which are these little bits here. So this is A, B, X, Y, start, Xbox, back, and then the D-pad here. And these little squiggles are, remember how the wire was broken? Imagine these as a broken wire. And what happens is the conductive pad comes down and touches these two sides and connects them via the conductive black pad. So you're essentially just flipping a momentary switch and telling the controller, if I hit A, all right, I'm pressing A, that command goes to this little chip here, which is the microcontroller for this controller, which sends data up into the Xbox or your computer and tells you what you're pressing. Easy enough. All right, so I'm going to take a little electrical tape. It's going to be a little tight. What I'm going to do is I'm going to chop this actually thinner. So now I just have a little thin line of electrical tape. I'm going to drop between these two wires. Okay, nice. So, janky, ugly, whatever. As long as it works, I don't care. And I'm going to put this back together. So we have a little, we have our shoulder buttons here. The controllers, whoop, let's get you in here. So we're going to drop the controller in. Rumblers in, so this goes in here, this goes in here, the controller sits flush. Look at the bottom, are all my buttons in the right spots? Yes, cool, good. Drop these back in. Pop on the case. Get you in the right orientation. That's correct. Drop in our back. So this is the second time I've done maintenance on this thing. First thing is I've replaced the control sticks with a wireless pair that I just don't use that wireless controller at all. And now I've hopefully fixed this wire. Fingers crossed. It's Slide that in, snap that together. Cool. I'm gonna plug this into my computer one more time. Make sure we get the lights. Now this computer isn't, actually, you know what? You don't have to do all. This is a nice little repair tip. Do as little as you can to travel between steps. And what do I mean by this? I want to test this out, and I want to make sure it doesn't... Oh, I did jingle that out a little bit. Oops. Oh, you got it there. I want to test this, and I want to make sure it doesn't fall apart while I'm testing it. So instead of putting back all the screws or my bolts, I'm going to put back in just like 2 or 3. That way when I'm using this, it doesn't fall to pieces on me while I'm trying to use it. But if I did mess something up, and I do have to crack this thing back open and fix another problem, I don't have to crack the entire thing back open. All right, that looks ugly, but let's see if it works. This is my computer here. This is my controller here. I'm doing a Windows update, but I think this works. I can play Sekiro again with this controller. So I've been playing for a good 10-20 minutes, and typically this would have disconnected by now, so grody as it is, it's working. Working. Cool. Mission accomplished. Ooh. All right, I've been reviewing the footage, and Nick is not pleased. Nick wants this controller to look better, so we're going to try something that I saw online. We have we got our electrical tape that we wrapped up yesterday. This is already going to be gunky and gross because electric tape always looks gunky and gross. I don't know what adhesive they use or the whatever. So the good news is the fix did work. The fix worked great. No complaints about the controller's functionality now. We're all good. My only complaint is that this looks awful. This looks terrible. I hate it. So what we're going to do is we're going to wrap it up. Don't be silly. Wrap that willy. And in order to find the right heat shrink, you just start somewhere. You look at the size. I'm debating if I kind of want to scrunch this down. Yeah, I think I can scrunch that down. But I'm going to need fairly big heat shrink in order to make that connection viable. So I'm looking through my options here. These are all the heat shrink sizes. If you're just starting out with, I don't know. If you're just starting out with repairs, it's good to get these sorts of boxes that just have varieties of sizes for the various materials you need. I do that right now with these threaded inserts for my 3D prints, for these M bolts and nuts. These variety packs are amazing because you never really know exactly what size you need when you're doing the repair. So it's good to try out a couple options. That's not the one I want. Some of these are way too big. Some of these are way too small. This yellow one might actually be the right size. Because in terms of diameter, if you want to get real anal retentive about it, you can get out your beautiful Nita Toyo caliper. This is the best thing that I've ever purchased in my life. This is my baby. Power that on. Loosen it up. Snap it back. Zero it out. And all I'm going to do is I'm going to figure out the best way to squish down these wires, which seems to be kind of like that. And then I'm going to crunch you in. So it looks like I'm looking at about 7.5 millimeters for this gap here. Let's see if any of these match that diameter. This looks a little too big. But if I diameter it up, yeah, that just feels too wide. We'll do the next size down. These look like they're all about the same size, so I might end up having to go with this slightly wider diameter. Let's try this one first. This tube might look a little short. No, let's try the yellow first. So this one was here. This one was here. So I'm going to take this yellow tube, and I just read this tip online. We're going to see if this actually works together. I'm going to snip you to size. So it looks like they're about, you know. I'm going to snip this down the middle. Now, allegedly, I can undo this, wrap this around, super glue it. See, that's not quite wrapping around, unfortunately. So the next size up from this, I think, is this black one, unfortunately. This red one might be thinner. I could go clear. Let me be clear. That seems a little too wide. I think red is my next size up. So we're going to try this one out now. Match the length. Go. Same thing, snip it down the middle. You know, actually with this I can drop this around. I think I can super glue this shut. much left in here, so I think I can just snip it. Yep. So I'm spreading super glue on one side here. I'm gonna wrap it around. I'm gonna push it down. Come on, come on. I'm try not to stick my fingers in it. Come on, come on, come on. There we go. Shit. Shit. Missed my chance. Let's try that again. Nice healthy bead. Great and horrible property of super glue is it's super fucking sticky. It's super quick, but it's super sticky and super quick. Come on. Okay. I think we got it. I'm gonna just layer it up. Oh, come on. I'm gonna just brush it over. Nice. All right. So, only got a little super glue on my fingers. And now we have that. Nice, nice. Used up the last bit of this tube of super glue. That's fine. And now let's get out my heat gun, which I think I left downstairs. So let me go grab that and I'll be right back. Well, fun fact, now that my fingers are covered in super glue, my password using my biometrics doesn't work on my phone right now. That's pretty funny. So instead of using my soldering iron, I'm going to use this heat gun because it's just nice and easy. It's a nice and easy way to apply heat universally and uniformly. Try to get a little drop in here. There we go. Looks like there's a little lip that was coming up, so. Now V8. Play with your gluey fingers for a hot sec. Seal it up. I think you hold it for like 30, 60 seconds to try to confirm the sealing. Like I said, I'm not the biggest fan that I gotta use red here, but let's see what happens. So this is a heat gun. All it does is it's essentially a blow dryer that gets really, really hot. Are you watching closely? Look at that. It's better. I kind of hate the red, so I might drop on a black on top of it as well. Yeah, why not? Honestly, if I snip off just this amount. And I do the same process. Snip it in the middle. Open it up. Wrap it over. I'm going to add a bit more overlap this time. Do the same thing. Drop on a line of super glue if I can. Feels like, yeah, there's still more in there. Add a nice streak. Super glue. Keep you down. So I can overroll you. Come on, there we go. Nice. Probably should have cleaned the surface first. Probably would have given me an easier time of it, but now it's looking better already. How long do I let you dry for? That's what I say. All right. Well, same deal. Turn it on. You want even heat. This helps too, going underneath. As heat rises. There we go. Oh, that looks so much better. It's still a little more wiry than I would like, but that's a hell of a lot better than the electrical tape. Just look at that. No more protruding little nibbits. Nice. Cool. Have a good one.